Hello everyone, I am Mohammad Irshad Ahmed and I am a final year student at Department of Electronics Engineering in Zakir Hussain College of Engineering and Technology, Aligarh Muslim University. In this video, I will be presenting my project work on the topic designing of 1:2 demultiplexer using Cadence Virtuoso. Before moving ahead, I would like to acknowledge the support received from the Chips2 startup or the C2S program of the Ministry of Electronics and Information Technology, Government of India provided to Aligarh Muslim University. This support facilitated access to industry standard EDA tools and associated training. The present work has been carried out as a part of our course project for digital IC design under the guidance of Professor Mohammad Wajid. Now let me take you through the complete design flow from schematic creation to GDS2 generation. A 1:2 demultiplexer is a fundamental combinational circuit that routes a single input data line to one of two outputs based on a select signal. Let me show you the implementation. Here you can see my project folder containing all the design files and libraries. An open terminal in this folder. Now I'll enter some command first to navigate to the directory where the Virtuoso file is stored, followed by giving the command to open the Virtuoso software. Now this command opens up the log file. Let me open the schematic of the 1:2 demux. Here is the transistor level schematic of our 1:2 demultiplexer implemented using CMOS technology. From this schematic, I generated a symbolic representation for hierarchical design and testing purposes. Let me show it to you. Here is the symbol view of our demux. This symbol makes it easy to instantiate the demux in larger designs and create test benches. Now, since that is done, let us run some simulations. First, I'll run the transient analysis. So I've set up a transient analysis for 100 nanoseconds to observe multiple switching cycles. Now let me select the outputs. I'll be choosing four outputs, which is the input I naught, select signal S naught, and outputs Y naught and Y1. Now let me run the simulation. You can see this result of the simulation. The detailed result and analysis is done in the report. Now that we have verified the functionality, let's move to the physical design phase. Here is the physical layout of our 1:2 demux created in Cadence Virtuoso Layout Editor. Different colors represent different mask layers as defined by the GPDK90 technology. After completing the layout, the first verification step is the design rule check or DRC. DRC ensures that our layout compiles with all manufacturing rules for the 90 nanometer process. Now the DRC is running here, and here are the results. The next verification step is layout versus schematic or LVS. LVS verification ensures that the physical layout is electrically equivalent to our original schematic design. I'm comparing the extracted netlist from the layout against the schematic netlist. So I'm running the LVS check now, and the results show that the LVS is clean, which means the comparison is successful. And since both DRC and LVS has been checked, we are ready for the next critical step, which is parasitic extraction. For that, I'll perform RC extraction using Quantus, which is Cadence parasitic extraction tool. Quantus extraction captures all parasitic resistance and capacitance from the physical layout that weren't present in our ideal schematic. Extraction has been completed successfully. Now let me show you the extracted view. Here you can see the original circuit with all the parasitic elements added. This extracted netlist represents the actual circuit behavior that will exist in silicon. The difference between the ideal and extracted view shows why post-layout verification is crucial. Finally, we export the verified layout in GDS2 format, which is the industry standard for IC fabrication. Let me show you the GDS2 file. This file contains the complete mask data and can be sent directly to a semiconductor foundry for chip fabrication. That was all in the project. Thank you for watching.